Okay. Let's balance an equation. Woo! Alright, balance an equation. Okay, earlier today we did some balancing equations, and I did one in which we had oxygen all by itself and reacted it with ammonia. And I was trying to show you a shortcut, but the shortcut fell apart in my head. And so I've stepped back and I've reevaluated the shortcut, and I'm going to show it to you again. And I think I understand it enough to be able to explain it to you. So let's take a look at it. Let's go ahead and balance this equation. So we have C2H6 plus O2 reacts to form H2O plus CO2. What is this reaction? Let's see. We have a hydrocarbon reacting with oxygen to form water and CO2. That is combustion, right? It's complete combustion too, because we actually have CO2 over here, not carbon monoxide. Is it balanced? Well, let's just see. How many carbons do we have? We have 2. On this side, how many hydrocarbons do we have? 6. How many oxygens do we have? 2. That sounds like that engine number 9, the one down the Chicago line, whatever. How many carbons over here do we have? We've got 1. Oh, that's sad. How many hydrocarbons do we have? 2. How many oxygens do we have? 3. Is it balanced? No, our carbons are off, our hydrogens are off, and our oxygens are off. We couldn't be more off if we had to, but that's okay. We will get it all under control. Over here we got 2 carbons, we have 1 carbon over here. I'm just going to go ahead and pick on this carbon because I have 1 over here and put a 2 here. Alright, put 2 in front of the CO2. That gives me now 2 carbons. That's awesome. However, now I've got 2 times 2 is 4 oxygen. 5 oxygen altogether. Right? 2. I have 2 oxygen here times 2 is 4 plus 1 over here is 5. So now my carbons are now balanced. My oxygens are off. How's my hydrocarbons? 6 and 2. Well, that's messed up. But it should be easily adjusted. I got 6 over here, 2 over here. I'm going to throw a 3 in front of H2O. That's going to give me 6 hydrogens. However, it gives me 3 oxygen here plus 4 oxygen here, a total of 7 oxygen. I have 7 oxygen over here, 2 oxygen over here. But that's fine because this oxygen's by itself. Alright, and I told you leave those elements that are by themselves alone to the very end and then attack them. Alright? So what do we got? We got 7 and 2, and here comes the shortcut. Right? The shortcut is we've got 7 oxygens over here, 2 oxygens over here. I'm going to multiply this by 7 halves. Right? 7 halves. And I know you're freaking out and you're saying, oh wait, no, you can't use fractions in front of these numbers because of that rule, Dalton's law way back when. But what we're going to do to make up for that is we're going to multiply everything by 2. Right? If we multiply everything by 2, we're going to cancel this 2 out. Right, so let's just see what that looks like. If we multiply this by 2, we're going to multiply this by 2. We're going to multiply this by 2. And we're going to multiply this by 2. Right, what will that give us? That's going to give us 2 C2. Hold on. 2 C2H6s plus 7 O2s react to form 6 H2Os plus 4 CO2s. Alright, 2 times 2, 4 CO2s, 2 times 3 is 6 H2Os, 2 times 7 halves is 7 oxygens, and 2 times 1 is 2 C2H6s. Right? Is it balanced now? Let's just see. Over here we've got 4 carbons. Right? 4 carbons. We've got 12 hydrogens. And we've got 14 oxygens. All right, what do we got over here? We've got 4 carbons. We've got how many hydrogens? 12. And how many oxygens? 6 plus 8 is 14. Look at that, it's balanced. All right, and we did that. We were able to do that so quickly because we did this little shortcut right here. And actually, I think your book has this shortcut in it too. All right, so 7 halves, again, we took what we needed over here, 7 halves, multiplied it by, we just took this number, this, and this, combined it for 7 halves, because we know we wanted 7 oxygen over here, right? To match the 7 oxygen over here, we put it over 2, and then we multiplied through by whatever number this was. So if this would have been 3, we would have put a 3 down here, right? And multiplied through by 3. Okie dokie, that was that.